All right, here's a thought experiment for you. Close your eyes. Well, not literally. You're watching a video. And picture the future of humanity in space. What do you see? Red dust? Domed habitats? Rovers trundling across an ochre desert? Mars. Always Mars. Every movie, every billionaire's keynote, every concept render. It's Mars, Mars, Mars. And look, I get it. Mars is romantic. Mars has sunsets. Mars has seasons, polar ice caps, the largest volcano in the solar system. But what if Mars is the wrong answer? What if there's a tiny frozen world hiding in plain sight? A place that's 1/4 ice, sitting right in the middle of the solar system's richest deposit of metals and raw materials. With the gravity so low, you could launch a spacecraft from it with a slingshot. A better bet for a permanent human colony than the red planet everyone's obsessed with. Its name is Ceres, and a growing number of scientists think it might be the smartest place in the solar system for humanity's next home. Buckle up, because this one is going to rearrange some furniture in your brain. Let's start with the basics, because Ceres doesn't get the press coverage it deserves. Ceres is the largest object in the main asteroid belt, that vast ring of rocky debris orbiting between Mars and Jupiter. With a diameter of about 585 miles, it's big enough to have pulled itself into a sphere under its own gravity, which earned it the status of dwarf planet in 2006, the same year Pluto got that famously controversial demotion. NASA's Dawn spacecraft orbited Ceres from 2015 to 2018 and revealed a world far more interesting than anyone had expected. Bright salt deposits in a crater, evidence of recent cryovolcanism, that is, volcanoes that erupt water and briny slush instead of molten rock, and most importantly, an enormous amount of water ice. How much water? Ceres is estimated to be roughly 25% water ice by mass. Let that sink in. 1/4 of the entire dwarf planet is frozen water. That makes Ceres, by some measures, the most water-rich body in the inner solar system after Earth itself. Dawn also found something that made astrobiologists sit up very straight in their chairs. Organic molecules on the surface near Ernutet crater. Not life, nobody is claiming that, but the kind of complex carbon-based chemistry that, on Earth, tends to precede biology. Ceres isn't just a ball of ice and rock. It's a ball of ice and rock with chemistry that hints at conditions favorable for prebiotic processes. That's not nothing. And water, as any space engineer will tell you, is everything. Water is drinking. Water is oxygen. Water is rocket fuel. Split it into hydrogen and oxygen and you've got propellant. Water is radiation shielding. Water is agriculture. In the economy of space colonization, water is gold, oil, and currency rolled into one. Mars has water too, sure. Subsurface ice, mostly at the poles, but extracting it requires drilling through meters of frozen regolith in an environment where the average temperature hovers around minus 76 degrees Fahrenheit. On Ceres, the ice is more accessible and far more abundant relative to the body's total mass. Point 1 for the dwarf planet. Just a moment, guys. Only 13% of subscribers know when we publish new videos. Make sure you subscribe and turn on the notification bell, because without it, you'll miss formats and documentaries you won't find anywhere else. Here's where things get uncomfortable for the Mars enthusiasts. Mars has gravity, about 38% of Earth's. That sounds like a reasonable compromise, right? Better than the Moon's 16%, better than 0G on the space station. Surely 38% is enough. The honest answer is, we don't know. And that uncertainty is a much bigger deal than most Mars advocates are willing to admit. We have decades of data on what zero gravity does to the human body. Bone loss, muscle atrophy, vision problems, cardiovascular changes. We know Earth gravity is fine, obviously, but we have exactly zero long-term data on what 0.38 G does to a person over years or decades. And here's the part that should give you pause. We have no idea whatsoever what it does to a child growing up in it. Will Martian-born children develop normal skeletons, normal cardiovascular systems, normal eyesight? Nobody can answer that question because the experiment has never been run. Finnish physicist Pekka Janhunen of the Finnish Meteorological Institute in Helsinki has been raising this flag for years. His concern is blunt. Children raised on Mars might never develop into healthy adults. Their bones and muscles, shaped by 0.38 g from birth, might make them permanent Martians, physiologically incapable of ever visiting Earth or even surviving in full gravity. Ceres' surface gravity is tiny, about 0.028 g, barely a whisper. If you weigh 154 pounds on Earth, you'd weigh about 4 pounds on Ceres. For surface colonization in the traditional sense, that's a non-starter. You couldn't walk normally. You couldn't pour a glass of water. You couldn't do much of anything that resembles human life as we know it. But Janhunen's proposal, and this is the part that changes everything, is to not live on Ceres at all. Instead, he envisions a constellation of enormous cylindrical habitats in orbit around the dwarf planet, each one spinning to generate centrifugal force that simulates Earth gravity. Not 0 g, not a compromise, gravity you can raise children in. The concept draws on an old but proven idea, the O'Neill cylinder, first proposed by physicist Gerard O'Neill in the 1970s. Each habitat would be roughly 6.2 miles long, with a radius of about 0.6 miles, completing a full rotation every 66 seconds. Just enough spin to push everything inside toward the outer wall at close to 1 g. Soil deep enough for trees, controlled weather, agriculture, parks, a genuine living environment, not a cramped metal tube. And Ceres provides the raw material to build all of it. The nitrogen for an Earth-like atmosphere, the water for life support, the silicate rock for radiation shielding. Using a space elevator feasible on Ceres because of its low gravity and relatively fast rotation, you could lift material from the surface to orbit at a fraction of the energy cost it would take on Mars or Earth. This isn't a napkin sketch. Janhunen published the concept as a detailed technical paper on ARXIV in 2021, complete with mass budgets, structural calculations, and energy requirements. His conclusion, the overall difficulty of building this settlement is comparable to colonizing Mars. The delta V is higher and the travel time longer, yes, but you avoid the nightmare of landing on a planet with a treacherous thin atmosphere. You dodge the unsolved gravity question entirely and get a habitat that can grow, not just sustain, grow, potentially to house billions. Now let's talk about location, because in space, location isn't just important, it's everything. Mars sits about 1.5 astronomical units from the Sun. It's relatively close. It's accessible. It has well-understood launch windows every 26 months. These are genuine advantages, and nobody denies them. But Mars is also, in a cosmic sense, a dead end. It orbits between Earth and the asteroid belt, and beyond it lies a long, empty stretch before you hit Jupiter. If your goal is to expand further into the solar system, to reach the gas giants, their moons, the Kuiper belt, Mars doesn't help you much. It's a waypoint on a road that doesn't go anywhere convenient. Ceres, on the other hand, sits right in the middle of the asteroid belt at about 2.77 AU from the Sun. And the asteroid belt is where the resources are. Here's a detail that surprises most people. Because of orbital mechanics, launch windows from Earth to Ceres are actually more frequent than those to Mars. Mars lines up for an efficient transfer roughly every 26 months. Ceres, despite being farther away, offers comparable windows more often, roughly every 15 months. If you're planning regular cargo runs and crew rotations, that cadence matters. The main belt contains an estimated billion metric tons of material: rock, metal, ice, organics. That's 10,000 times more than what's available in near-Earth asteroids. Iron, nickel, platinum group metals, water, carbon compounds, the building blocks of an industrial civilization floating in manageable chunks throughout a vast orbital highway. A colony at Ceres would be the natural hub for mining operations across the entire belt. Its low escape velocity, just 0.32 miles per second, compared to 3.1 miles per second for Mars and 7 miles per second for Earth, means launching spacecraft from Ceres costs almost nothing in energy terms. You could dispatch mining ships, receive processed materials, refuel and resupply with local water, and set goods inward toward Earth-Moon space or outward toward Jupiter and beyond. Ceres is not a destination. It's a crossroads, and crossroads are where civilizations build their most enduring cities. Now, let's be honest. No hand-waving, no cheerleading, just honest, because gospel enthusiasm without intellectual honesty is just noise. Ceres is far. At its closest approach to Earth, it's still about 1.6 AU away, farther than Mars ever gets. At its most distant, about 4 AU, one-way communications take between 14 and 33 minutes, depending on orbital positions. That's noticeably worse than Mars, where the delay ranges from 4 to 24 minutes, and it's enough to make real-time conversation impossible and emergency coordination a genuine challenge. Travel time is longer too. With current propulsion technology, a crewed mission to Ceres would take roughly a year and a half one way, compared to about 7 to 9 months for Mars. That's a serious commitment, both physiologically and in terms of radiation exposure during transit. Then there's the cold. Ceres receives far less sunlight than Mars, only about 13% of what Earth gets, compared to 43% on Mars. Surface temperatures average around minus 157 degrees Fahrenheit. Solar power is less efficient. Heating requires more energy. Everything about energy management gets harder. And let's not forget the elephant in the room. We've never sent a human being beyond the moon. We haven't landed people on Mars yet. The idea of skipping Mars entirely and going straight to Ceres strikes many in the space community as putting the cart before several horses and at least one rocket that doesn't exist yet. These are not trivial objections. They deserve respect. Because the people who think longest and hardest about humanity's future in space have started to notice something that short-term thinking misses. Mars is the easier first step. Nobody disputes that. But a Mars colony built on the surface under 0.38 G with a razor-thin atmosphere and no global magnetic field may have a hard ceiling on how far it can grow. You can build domes. You can grow potatoes. You can plant a flag and stream it live and sell the movie rights. All of that is real and all of that matters. But can you build a civilization there? Can you raise generation after generation of healthy children? Can you scale from 100 colonists to 1 million? Can you use Mars as a springboard to reach the rest of the solar system? The Ceres model answers those questions differently. It says, don't trap yourself on a planetary surface with the wrong gravity. Build your own habitat. Engineer the gravity you need. Use the resources that are most abundant and most accessible. Position yourself at the nexus of the solar system's richest material belt. And design a system that can grow. Not by building another dome next to the first one, but by manufacturing another cylinder and linking it to the network. It's a vision of space colonization that doesn't depend on finding or creating the right planet. It says we'll build our own world, thank you very much, and we'll put it where it makes the most strategic sense. Is it harder to get to than Mars? Yes. Is it a longer-term project? Absolutely. Does it require technologies we haven't fully developed yet? Without question. But remember, when Gary Flandreau spotted the Grand Alignment in 1965, nobody had built the Voyager probes yet either. The technology followed the vision, not the other way around. The real question isn't whether Ceres is better than Mars. That framing is too simple. The real question is, what kind of spacefaring species do we want to become? If the answer is one that plants flags and builds outposts on nearby worlds, then Mars is the obvious next step, and we should get on with it. But if the answer is one that expands across the solar system, builds sustainable habitats, and isn't permanently tethered to the gravity well of any single planet, then Ceres deserves a seat at the table, a prominent seat, maybe the head of the table. The dwarf planet in the asteroid belt isn't glamorous. It doesn't have sunsets. It won't get its own Hollywood trilogy anytime soon. But it has water, nitrogen, organics, a strategic location, a negligible gravity well, and the raw materials to build a new world from scratch. Sometimes the best answer isn't the most obvious one. Sometimes it's the small, quiet, ice-covered rock that nobody was paying attention to. But before we leap to Ceres, or anywhere beyond, we have to make it back to the moon. And Artemis astronauts will face risks Apollo crews never encountered. Watch next why Artemis 3 and 4 astronauts face new dangers in 8K. The link is on the screen now.